What is a molar mass of methane? So now this is where it gets a little bit fun. In fact, I'm actually gonna ask two questions based on this, just so we can cover our bases here. So right now this is asking for molar mass of methane. So I'm just gonna say and octane. Okay. Now the reason why I'm saying that is because you gotta get really familiar with your nomenclature, the naming, because just to break it down, if they said it like this, it would really suck for you to know how to calculate molar mass but not know what to calculate. So when you go through the nomenclature, click this. So meth, oops, I'm gonna use a different color just to show. So it's meth, F, pro, bute, pent, hex, hept, and O, and then it's like 9 is like non-deca. No, non-decane. That's like 11. Octane. Usually stops as octane, so I just stop there for now. But in your book, it might go further. But these are the most important ones, at least to me. Meth is 1, eth is 2, prop is 3, bute is 4, pent is 5, hex is 6, hept is 7, and oct is 8. The reason why I did that is because you're probably wondering, what does the 1, 2, 3, 4, 5, 7, 8 even mean? That's the amount of carbons that they have there, okay? And for these hydrocarbons, exactly, that's what their name actually implies as well. Hydrocarbons, a combination of hydrogen and carbon, okay? And the way these work, the anes, they are saturated hydrocarbons, aka every bond is filled out, like every carbon has as many hydrogens as it can take. So that's what that A and E means, okay? And when that happens, there's actually a certain formula you can use just to be able to quickly find out how many hydrogens you have. Hence why we have octane then is there as well. So methane, meth is 1, okay? But let's just stop there real quick as I mentioned the formula. So C, N, okay, so whatever amount of C there is, there's going to be 2N plus 2H. But this only counts for things like the anes. You need a different formula for the ines or enes, which is like double or triple bond. Only counts, okay? So, with that being said though, let me just right there, only counts for full, so anes, which is the hydrocarbons. So with that being said, how much hydrogens are in methane? So if we use our formula here, if C was 1, okay, H is 2 times 1, that's 2, plus 2, that's 4. That's how much for methane. Octane, for example, now, C, 8, 2 times 8 is 16 plus 2, 18. That would actually be the composition of octane, okay? But they're asking for the molar mass, so same thing here, you know? We're going to break it down. There's 1 carbon, 4 hydrogen, and here there's 8 carbon and 18 hydrogen. Hopefully I have enough space for this. So 1 carbon times 12.011, and then this is 1.008. And then we can just move this to the side. Oops. And so that's 12.011 plus 4.032. (16.043 grams per mole of CH4. So just put this under then. Okay, so with that, that's for methane. Now if we were solving for octane, same thing, was like we just have a much bigger number. 1 and then 18 times 1.008. So 8 carbons, so 12.011 times 8, 96.088. And now the hydrogens, 18 times 1.008, 18.144. Moves 144. Okay, and we add that together. (114.232). That's the weight of octane. So C8H18. That will be how you answer these questions. Now with this, they got what we got for the CH4. The numbers, as I mentioned, are slightly different because of their periodic table. But now I'm curious to see if that way we're doing it actually works for even bigger molecules. So I'm going to do here is search up octane molar mass. And actually, it says there 114.23, which is also what we got from our periodic table. So with this though, this solution is correct, because that is what they did exactly, is exactly what you should be doing to find the molar mass. And just to review, they had the carbon, they had the hydrogen, they multiplied the hydrogen by 4, okay, and then they added it together. So that is how you do it. And now for number 10.